Okay, so you got to really be careful at the denominator, so you might, depending on how you guys do it, definitely have parentheses around the top and parentheses around everything on the bottom, but you're getting something that kind of goes like this, like that, isn't it? Yeah. Now, they're asking me to approach 2. But what happens when you plug in 2? I get 0 on top. 2 plus 2 in the first square root would give me 4. What's the square root of 4? 2 minus the square root of 2, right? So what's happening? Am I getting a value?
Yeah.
What's 0 divided by 2 minus the square root of 2? 0. We end up with 0 divided by 2 minus the square root of 2. I mean, that's going to be an ugly decimal, but it's an answer. So 0 divided by something works. So it is 0. It's right there. So the visual that you have to understand is you are going to go over to the negative side of that input, and you're going to work your way in on the number line. You're going to go from the positive side and work your way in. So as you come in from the negative or left-hand side, the graph, the outputs are coming up to that dot, right? And as I work my way in from the positive x's, my outputs are up here and they're coming down here. So those pink or that purple arrow, where are they meeting? They're coming together, right? The purple arrows or the pink arrows are coming together and it's coming to 0. So you can tell your limits. Even if there was a big hole there, it would come towards that hole, it would work. How about the limit of the cosine of x?
It's just like almost a straight line.
Remember, you start at 1, 0, pi over 2, pi, 3 pi over 2, out to 2 pi, down to negative 1. So the graph starts at its maximum, goes to the midline, minimum, midline, maximum.
I got something way.
You probably didn't switch back to radian mode.
No, I did.
We're trying to approach.
Wait.
We're trying to approach pi, right? So as you come in, well, you need to switch your window too. You got to go from 0 to 2 pi or 0 to 360, but depending on degree of radian mode. So as you come in from the negative side, you're going to follow the graph. It's going to take you down the valley. As you come in from the positive side, it's going to take you down to the valley. And so
Pi over 2, pi.
on both sides, we're following inputs down to here. Where are those 2 red arrows coming together? At an output of output. What's the output down here? Negative 1. Outputs are the y values. So as your x's get closer and closer to pi from both sides, my outputs are way down here in the valley of that graph, and it's close to negative 1. So tables and graphs, it's all about get close to it, what's happening on either side. Conditions under which limits do not exist, we're going to kind of fly through these. If I graph it, if you graph this, what happens when you plug in 10? What's 10 minus 1?
9.
What's 10 minus 1?
9.
What's 9 over 9?
1.
So when I'm at 10, I'm at 1.
What is 1?
When you plug in 5, what do you get? 1. What happens when you plug in 1?
0.
No.
Undefined.
So as you plug in numbers on the right-hand side, or the positive side of 1, so plugging in 10, 9, 8, you're going to get a 1, a 1, a 1, a 1, a 1, 1, all the way across. When you plug in numbers that are on the left-hand side of 1, like negative 10 minus 1 is negative 11. What's the absolute value of negative 11? 11. What's negative 10 minus 1? So on this side, what are you going to get for outputs every time? Negative 1. So this is up at 1. This will be down here at negative 1. And you're down here. But when you try to plug in 0, or excuse me, the 1 again, I should maybe make that red. So you're trying to approach 1, but you can't use it. It'll error out on the function. So if we trace the outputs from both sides, would the arrows be coming together? Do my fingertips come together? No, they're in two different locations. Different number from the right side of C than the left side. So this would not satisfy condition number 1 here. So this is a rule number 1. This does not exist.
Wait, why?
That's a D. Does not exist. Because it approaches different values, right? What about 1 over x when you look at that graph?
Yeah.
Remember, it's here from 2, 6, 2, 7. We know that the horizontal asymptote is at y equals 0. The vertical is at x equals 0. So if you try to approach 0, what happens on the positive side? If you come in from the right, what's happening to the outputs as you get close? No.
It's going up.
It's getting really big.
It right here, when it gets in here close to 0, all of a sudden it starts to explode in the upward direction, right? And as you come in from the negative side, the left-hand side, right? Explodes down in the negative direction. So my values are definitely going to two different locations, right? This one is actually satisfied. Rule number 2 here is that it's increase or decrease without bound on both sides of that particular limit. The last one, if you look at it, let's just graph it. So was it 1 divided by cosine of x?
Cosine.
Is it just
C.
like that? Yeah. Okay. Mode, I will switch back to radian mode.
If we.
See it? Okay. Then I'm going to switch to negative to 5. To 5. So I'm just going to keep. Negative 1 to 1.
What the heck?
Negative
You're
0.5,
artist.
0.5. A little here, negative 2 to 2. We keep getting closer and closer and closer in this thing. I mean, you keep expecting it to eventually, like, we've zoomed in enough, and you can just see something, but as we get closer and closer and closer, it keeps looking like a barcode, right? And this is actually an example of rule number 3. Does not exist. It oscillates. I don't know, it kind of, did one of those. This one does not exist. I wish my D's would look a little better. Okay, so those are rules in which they do not exist. There are some properties which you can look at. We don't spend a lot of time on them. And now we're ready to actually calculate some limits.